Okay, so here's 106. And so first we're going to prepare a classification model. And this is a support. It's the one from 105. Let me find out what it was. It was this classification model. I think it was a wanted to say what kind of model it was. There, just a linear model, a binary classifier, stochastic gradient descent, just a linear classifier like this, with one layer of neurons to do the work. So that's going to be here. And then we're going to poison this model. So we start with this code. And I guess it's, yes, preparing the container we're working in. And there it is doing things, fetching the data. Little green arrow tells me where we are. All right, so it's going to fetch the data and print out some results with the MNIST training set. And this will be good for viewing the predictions. Got to wait for the previous block to finish. Okay, there we have some predictions, correct and predicted. It looks like it got all of the first 5 correct. And this shows how many it got correct. Here's how many mistakes it made for each of the right values. So you see, it's pretty well. It only got 2 1s incorrect. And the important thing here is to see it got 2 1s incorrect and 12 2s incorrect. And we're going to try and confuse this model so it can no longer tell a 1 from a 2 so accurately. So we first summarize the training and testing set to see what data we got to work with. And so this is what we have, how many in the training and testing set. So the training set contains about 200 of each of these, and the test set contains approximately 100 of each of these. All right, and so now we're going to poison 10 of the ones. This is going to go through, and it's going to change 10 of the 1 labels to 2 labels. This is the simplest attack on a machine learning model, is if it had the wrong labels. We're not changing the images. We're just going to change the labels. So some of the ones that are really 1s are going to be labeled as 2s. And that, you would think, would decrease the quality of the model. So if you train from the poison data, then you get almost the same results. The only thing that happened is we got 11 2s incorrect, and before we had 12 2s incorrect. So in fact, the model, or say before we had, before we had 12 2s incorrect, now we have 11 2s incorrect. So the model actually works better with the first 10 instances labeled. So the poisoning has not yet done anything at all. So if we change it to poison 30 of them instead of 10, so I can go back to here and I'll poison 30. All right, now we've changed a bunch of the 1s to 2s. So before we had 221s, now we only have 191s. Now we have 30 more 2s. So 30 of these 200 instances have been mislabeled. Now we should hopefully see some performance degradation. Now we're getting 13 of them wrong instead of 12. So we are beginning to get more of them wrong. So you can see it does work. It has an effect, and you have to poison an awful lot of them at this model to see any change. So that's a weak attack, mislabeling some of the data. It takes a lot of errors in the data to ruin the model there. Now let me stop this one.